Welcome to Occupations, the podcast, where we discuss what it's like to hold specific jobs. Occupations is brought to you by lotsofmaps.com, where you fulfill your vintage map gifting needs. Visit lotsofmaps.com.
Hello and welcome to another episode of Occupations, the podcast. Today we have a special guest, and by the way, we're using new technology for the first time in Occupations history. Yes, all 18 episodes. We are actually talking to someone over the phone versus being face-to-face with them. And today's lucky subject is Ruth Heffernan-Marsh. She is a principal engineer for offshore wind at DNV, and we're talking to her from the outskirts of Seattle, Washington. Welcome, Ruth, to Occupations.
Thank you so much, Andy. I'm really thrilled to be here and thrilled to be talking with you today.
Ruth, tell me a little bit about your job. Principal engineer, so we understand what an engineer is, I believe, but offshore wind, so we know you're dealing with some sort of current, and I'm assuming something to do with turbines or windmills or whatever you or other people call it. So tell me how wrong I am about that guess.
No, everything right that you said. Yeah, so offshore wind is the division, I guess I should say, of the industry that's focused just on putting wind turbines, which I suppose most people have seen somewhere or other in their driving around the country, various places. You've seen modern day wind turbines that are producing electricity. And in the United States, most of them are onshore, meaning on land somewhere. But we're starting to put turbines off the coasts of the United States on the East Coast and the West Coast, like has already been being done in Europe for about 20 years now. They've been putting turbines out in the North Sea and northern Germany, off the coast of the UK, off the coast of France, in the Mediterranean. These are, again, producing electricity just like the onshore wind turbines. The reason why, people might ask, well, why offshore? That seems a lot more complicated, which is true, it is. And the reasons are, in Europe, there's just a lot less land available to put turbines onshore, or say in the British Islands and things like that.
Sure.
And also, there's a lot of population that lives near coastlines, within, say, 50 or 100 kilometers of a coastline. I think worldwide, it's something like between 60 and 80% of people live that close to coastlines.
Wow.
And so if you can get the generation of electricity, the closer you can get it to the populations that are going to be using the electricity, the more efficient that is of the, transferring that electricity.
Yeah, I mean, that makes a lot of sense. And we certainly have a lot of open land in our country, in the Midwest and in the South. And all right, I'm going to ask you the most basic question. Now, I know you're not grinding anything, so I assume that this is the reason why, but why we call them turbines versus calling them windmills? Because certainly that's something that is kind of rejected by folks in your position.
Yeah, I mean, we don't mind if somebody calls it a windmill because, that's a thing with a rotor that goes around. And yeah, the original wind devices, I guess I could call them, go back hundreds of years. Actually, the original wind energy generators go back to the Persian time of like 900 AD or so. They were vertical axis turbines, and those were used for grinding grain, as were the Dutch windmills for early years. And those are mills. Yeah, because you're milling the grain or whatever it is. And then once they started producing electricity, that became the standard to call them turbines. Honestly, I'm not sure there's any particular connection between, turbine. I guess we have gas turbines and other kinds of rotating equipment that's generating electricity. But basically, if it's generating electrons, it's a turbine.
Okay, that makes perfect sense. So stop calling it a windmill, everybody. Stop it. So you're an engineer. Just give us a wide overview of what it is that your job requirements are and what it is you do.
So I'm like 39 years into my career at this point. So what my job as an engineer has entailed over those years has evolved. So right now, I am with a team that we are the offshore wind team for North America. I work at a consulting company, DNV, that stands for De Norske Veritas, which is Norwegian. It's a Norwegian company, but we just go by the initials. And primarily our overarching focus is to facilitate the energy transition around the world. Our company has offices in 120 countries.
Wow.
Away from fossil fuel-based generation of electricity and towards renewable energy or cleaner sources at the very least. And so again, I'm specifically in the offshore wind space, and we're supporting developers who are trying to build projects. We're supporting government research. We work with government agencies, again, with developers, with builders who are and installers. We work with various entities that are somewhere in the supply chain. And what am I doing? So my technical expertise is in the mechanical and aerospace engineering are the sort of the roots of my expertise. But so I started off doing blade design. So I will do consulting on blade issues. So we will do studies on things like supply chain challenges. What are the bottlenecks? What are the needs that are coming? Like if we want to build this industry here in the United States, what are the pieces that have to come together? I've been involved in government research, supported efforts to understand the different types of automation that could come into play in maintaining offshore wind projects. And what I'm talking about there is like using underwater robots and different kinds of sensors and things like that to try to keep tabs on the state of a machine and if there's any problems with it, and then what automated tools can be brought out to use to fix things like that. That also goes for the blades themselves. Historically, to fix a problem on a blade, if it's not too serious, you can leave the blade in place and send a person up there to rappel down and make a fix. Nowadays, there are robots that are being designed and deployed to do that kind of work. And that helps make it a lot safer for, when you're deploying things offshore, you've got a lot more complexity and just the challenges of the environment between waves and storms and things like that. You can't do maintenance on a machine in the storm.
Right,
You have
right,
to wait
sure. Even the
till the
robots
waters
probably
are
don't like
calm.
that very much.
No, they can't. Yeah. It's not like robots are going to take over in any way, in any case. They're just going to be used to do the most dangerous tasks, and then humans do the things that they are good at. You would never have just robots that they would take over all the maintenance of a turbine.
Right.
But there are certainly things that can be done. I was also doing a lot of training. We developed a training program that has been pretty widely attended by people in the industry, particularly from the government permitting agencies. They'll send their new staff or retraining staff for offshore wind that's sent through our training program.
And is this for maintenance or for other
No, this
training?
is good question. This training is for developers and anyone, the people involved in the supply chain or who want to be involved in the supply chain, who want to gain a basic understanding of the overarching aspects of the industry. So it's a short course. It's just a 3-day course that basically goes from the very beginnings of feasibility studies you might do to figure out if a specific area of the ocean is even worth pursuing to put a project in there, all the way through to the very, very end of the life of a project, 30, 35 years later, the decommissioning of that project. And the 3-day program kind of marches through that timeline and touches on all the different aspects that are involved in basically bringing a project to life and then, operating that project and then, like I said, decommissioning it at the end of its life.
Sure, that makes
So
sense.
it's not the level of detail. There are lots of programs that are in place, probably mostly on the East Coast, but coming up on the West Coast as well, training programs of different aspects to train technicians for offshore wind. There's electrical aspects to it. You've got high voltage. These projects that are going in on the coasts are ranging in size from like half a gigawatt to a gigawatt or more size of the project. And that would be a whole group of turbines that are, all the electricity is getting collected up and sent to shore. And then, that gigawatt of electricity is enough to power, 500,000 homes or something like that.
Wow. So you're designing blades, let's say, and I'm sure that's just a small part of your job, but give me an idea of, other than making it more efficient, why continue to design new blades?
Great question. The idea of more efficient is probably the lead driver of any design change.
Sure.
Because that's more electricity that you can squeeze out of the other end. But other reasons you would be designing new blades are, well, for offshore wind in particular, the biggest change that's happening with turbines from onshore to offshore is that they're getting much bigger offshore. And that's mainly because, well, two reasons. One is there's sort of no physics-based reason why not to go as big as you can. Whereas onshore, you've got all kinds of constraints, so like bridges and tunnels and things that you just can't fit something that's too big for the tunnel if you need to transport something.
Right.
And that's a very strong constraint that's hard to get around. For offshore, well, if you build a bigger blade, maybe you need a bigger boat, but you can build a bigger boat. That's what I mean by physics-based, or there's not like physical constraints. Sometimes there are bridges in the way, but then you would just build your blade facility on the other side of the bridge, or there's ways around it. And so with things getting bigger, you would need to design a blade for that larger size, and you might think, well, gee, just scale the thing up. But it doesn't work that way. You have to find ways to make the blade lighter. If you just scale something up, of course it gets heavier and bigger because you've scaled it up. But if you just do that sort of as a straight ahead scale up, the blade's going to be too heavy to be efficient or cost effective or whatever. So you have to be clever about how you do that scale up in order to make sure that it's going to be buildable.
Yep, that makes sense.
Full disclosure here, I started my career doing blade design after I left my first post-college job, but I haven't done that specifically for a while. I've consulted on that. That's more of a job that someone who's working for a manufacturer would be doing.
Sure.
But there are other things that are being improved as well in terms of like making the leading edge more resilient to being eroded away, because that can degrade the performance. There are things that can be done to the trailing edges of the blade that make them quieter. A lot of that has been based on the shape of whale fins. They have these little bumps on their trailing edges, and those smooth out the flow, and that's been applied to wind turbines as well. And then the tip shape is another area of research. Again, that can help with making them quieter and also more efficient. There are reasons besides just efficiency for why you would be continuing to try to improve that. And I don't know, engineers just can't stop trying to improve things.
That's why we love you so much.
Well, the other, and the other main thing is to try to reduce cost. So, you're constantly looking for ways to make sure you have the appropriate amount of strength and resilience in a blade, but you don't want to over design it because then you're just leaving money on the table.
Right. That makes sense. All right. Let's take a step backwards in time to little Ruth Heffernan-Marsh. And she was going to school. Where'd you grow up, Ruth?
I grew up in Worcester, Massachusetts, or I should say Worcester. Worcester, Mass.
Was there a particular age that drew you towards engineering, or was there something with wind turbines that said, this is where I'm going? At what point did you do that?
Yeah, great question. Not wind turbines per se. They were not on my horizon, but I would say it was the environmental and maybe more so the energy aspects of renewables that first grabbed my attention. And this happened during the Carter administration. which I had to look up because I couldn't quite remember. I thought it was middle school, but actually that was squarely when I was in high school, because Carter was president till 81 and I graduated from high school in 81. That was also the time of the OPEC oil crisis, and we were all sitting in gas lines trying to fuel up our cars, and renewable energy had its modern day resurgence as a result of the OPEC oil crisis. And the way that came to me was through my dad. He was an economics professor at Assumption College in Worcester. He was an economics professor by profession, but he was a poet dreamer by nature. When he would talk, he talked to us a lot about economics and sort of gave us economics lessons almost by just couldn't help himself, around the dinner table kind of thing. And he would talk about things like we had a big vegetable garden growing up, me and 4 boys. That's a lot of mouths to feed. I had my 4 brothers. And he'd talk about, the sharing economy, trading the neighbors with, you trade your zucchinis for some squash or to borrow a ladder or, whatever, that kind of thing. He loved that aspect of economics. He was not the egghead economist type person.
Sure.
And then he got so excited about the idea of exploiting a free resource, namely the sun, that shines down on everybody. It's not discriminating and whatever, and that you could take advantage of that and make something useful out of it and kind of exploit that resource, so to speak, without diminishing it at all. And in January, Worcester, Mass, it gets cold there, rain, snowy and all that. Middle of January, I remember him being out in the yard. Our yard was like the sledding place for the neighborhood. We had a lot of kids in the neighborhood. And he had his homemade solar cooker that he'd made out of tinfoil and cardboard, made a little looked like a satellite dish type of thing with a coat hanger kind of bent around to make a little stand for a cup to be sitting at the focal point, and heating up cups of water for the neighborhood kids to make hot cocoa while we're out sledding in the freezing cold January. And of course it took like 3 to 5 minutes per cup.
But hey, it was free and it was a good lesson in life, free. Right?
I just loved that whole idea. And of course, as soon as the tax credits came out to put solar panels on your roof, he put a couple of solar thermal panels on our roof and would excitedly call from the basement down by the water heater, like, oh, the water's heated up to 85 degrees just from the sun today. And we only have to pay for 85 to 104, whatever it was we were heating it to. He never said you should study engineering. Nobody said that to me, but I always grew up feeling from both my parents, like, you could do anything. My mom, on the other hand, she was like the math science person in our house. She was a nurse by training and she loved nursing. But she would talk to me about how, in her day, it was kind of like if you want to go to college and all that, you become a teacher if you're a woman or a nurse. Those were sort of the basic options. And she really loved being a nurse herself, but that she just knew she didn't have other options. And I always grew up feeling like I did. I could be whatever I wanted.
Sure.
I had that feeling from both my parents. And I also did a lot of sailing when I was growing up. There was a community boating program in Worcester where I grew up. My brother and I spent many summers there and even became instructors and so on. So I think that kind of planted the seed a little bit for getting into wind later on. But that was something that I really loved doing. I even raced sailboats in college as well, and gave me kind of a visceral feeling of just the wind in general and how to read it and just have that kind of understanding of how it works and all. So then in high school, it was just really obvious to me that I wanted to pursue engineering in college. And I ended up kind of a little bit of a fluke of why I even decided to apply to MIT, but I did, because Worcester has, Worcester Polytech is there, a very good engineering school.
Mm-hmm.
My older brother went there. But anyway, I got into MIT and I was obviously really excited about that. And right when I started college is when there was a change of political winds in the country, and all the funding and research and so forth was for renewables was kind of shut down pretty quickly there were even projects at MIT that I had seen when I was applying that got canceled. By the time I got there, they weren't doing that anymore. So that was disappointing. But, I just thought, well, I'm here. Might as well study mechanical engineering and just we'll take it from there.
Sure.
When I graduated, there were no opportunities in renewable energy or in solar. And for me, renewables really just meant solar. I didn't really know anything else. Since I couldn't really fulfill that goal, my next goal was, all right, I've never been to California, so I want a job in California. I just looked for opportunities on the, job board in the careers office, and there was an opening at NASA in Mountain View, California, NASA Ames Research Center. So I applied for that, and I got hired, sight unseen. NASA didn't fly you out for interviews or anything like that. It was an over-the-phone thing. But I thought, it's NASA, for Pete's sake.
Yeah, really? How impressive is that?
And I did tell them, I'm a mechanical engineer. I didn't know anything about aerospace, science, technology, whatever. And they said, well, you've got a good record. And they were hiring fresh out of school. They knew that their salary was low compared to, if you're in a different industry or something. So they compensated for that by offering the opportunity to take graduate courses part-time while working.
Great.
So that was how I got an aerospace degree. And that was the closest school to NASA was Stanford. Darn.
Oh boy, you got stuck there, huh?
I got stuck. So that's where I did my a master's in the aerospace department there and got trained for the work that I was doing at NASA.
Terrific.
And that was super fun. Yeah.
So even though you didn't have the experience that maybe they were particularly looking for, they were certainly willing to give you that education on top of it all, on top of your mechanical engineering, which must be
exactly
a bonus for them, right? Because you're getting two versions of the best Ruth Heffernan-Marsh.
Yeah. I mean, it was, they were hiring young engineers on purpose to help, kind of train them into the work that we were then doing. And that was super, super interesting. And so the group I ended up with there was called the Rotorcraft Aeromechanics Branch. And maybe that's a hint at how I ended up in wind. But, again, rotorcraft, I'm like, what's that? I know what a helicopter is, but it was an incredibly interesting job. I did both computer analysis of computer modeling of all the loads and behavior of the helicopters. And then we also had a wind tunnel. We had the biggest, actually NASA Ames has, I think 47 or something wind tunnels for testing, all the way from subsonic, which would be like rotorcraft or the kind of aircraft that we fly, up to supersonic wind tunnels. And those you're just testing little models of things. But the world's largest wind tunnels are at NASA Ames, and those are the ones that we were using to test large-scale models. Actually, the biggest wind tunnel was, I wasn't involved in this test, but they were able to test a full-scale F-18 fuselage in there. So that's how big we're talking. They're really pretty stunning. When you're driving past there on the highway, you look over and you're like, what are all those really odd shaped buildings?
So did you ever climb in there and try to fly and see how you do?
Not when it was running, but definitely was in there a lot when it wasn't running. One of the most fun things about working for NASA was underneath one section of the largest wind tunnel. It was called the 40 by 80 wind tunnel because that's the dimensions of the test section, 40 feet high by 80 feet across. And there was a big, just really dusty storage area. And in there, I'm not kidding you, was one of the Apollo capsules that had gone up. It wasn't one where the astronauts had landed on the moon. It was one that went around the moon a few times and then came back. I think it was Apollo 16 or 17, one of those, was in that storage area covered by a big tarp.
Wow.
And when my brothers would come and visit, or anybody would come and visit, I would always take them in there. Like, it was not guarded or anything. Like, anyone who worked there could just go in there. And we'd pull the tarp off and we'd climb up inside and lay down in those cots and like look at the control panels and just imagine, oh man, what it would have been like to sit on the top of that rocket and get shot into space.
What a great opportunity that was.
Yeah, that was amazing. Eventually, I think right around the time I left NASA, they had taken that capsule to give to a museum somewhere. So not
You
there
can
anymore.
maybe visit it every once in a while and say, hey, listen, I've already been in this thing, so you're going to have to let me go back in
Right.
again.
Right.
So you find yourself working for NASA. What did that lead to? What was next step in your education and your work history?
So yeah, so what happened was, even though I really enjoyed that job, I did feel like, wow, I'm kind of going off track here. And even with my graduate work, I was like, again, technically interesting, academically interesting, but not renewable energy related, until I went to a rotorcraft short course that NASA had sent me to. And two people who were attending were with the Solar Energy Research Institute. So I pigeonholed one of the guys at the first break, and I said, what is this? He said, well, they were working on wind turbines, and they're trying to learn more about rotors and rotor aerodynamics and rotor dynamics, all the stuff, literally the stuff that I had been not only working with at NASA, but also studying at Stanford. And the light bulb just went off in my mind, and I thought, oh my gosh, maybe I'm not so sidetracked. Maybe this is all, leading to something different. So it took a couple more years. I also shared my enthusiasm or my desire to work in renewables with my coworkers. So they knew that I was interested in that sort of thing. And one day, I think it was about 6 years after I'd started at NASA, where one of my coworkers put an ad on my desk from the local San Jose Mercury News, and it was for a wind turbine manufacturer that was in nearby, that was looking for an mechanical engineer, whatever. Anyway, well, I looked at all the description and I thought, okay, yep. All these things that I had been doing for the last, 5-6 years. So that was like the most fun work interview I ever had.
So give me an idea of where we are in the history of turbines. I'm assuming there were existing turbines that were doing some work at this time, or no?
Yes. Yeah, good point. So that was 1991 when I left NASA and went to work for this company. And by that time, the modern day wind turbine industry, the roots of it were the early 80s. And it first got kicked off in Denmark. And that's because in Denmark, as other countries in Europe, they were really hammered, even worse than the United States, by the embargo. Denmark had been importing like 95% of their energy needs in the form of oil from the Middle East, the OPEC oil. So they were completely shut down. So they were the ones who immediately scrambled and thought, what the heck can we do so that this doesn't happen again? And they looked around and they said, we got a lot of wind and we have farm equipment manufacturers. Maybe we can repurpose them to, try to make wind turbines. And so they got that started. And then the US was also doing research back in the early 80s, late 70s, again, like during the Carter administration. And then there were also government incentives, tax credits and things like that were kind of trying to spur this industry. And that was a mixed bag because it did increase some interest, but then there were a bunch of companies that came in that were total fly-by-night or even outright fraudulent, that were building complete garbage and putting it out in a field and saying, yeah, that's a wind turbine. And so the industry kind of got a bad name. But then, there were multiple cycles, kind of boom and bust cycles for the renewable industry in general. And in the early 90s, it was another boom cycle where there was, instead of the kind of tax credit scheme that they had initially started, they came up with a new idea, which was called a production tax credit, where you're giving a tax credit on the amount of electricity you're producing. So you can't fake it. You either got electricity at the meter or you don't. And you can't just say, like, look at that thing over there that I made. It has to work. And so that was sparking a real look into how can we engineer these turbines better than what had been done, say, in the mid 80s. And that's when I got started in the industry. So The company I worked for, their name was Kenetech Wind Power, which doesn't exist anymore. It went bankrupt after about 5 or 6 years when I was there. But at the time, Kenetech was the largest wind turbine manufacturer in the world. They were kind of trying to be, and in some senses did succeed at being kind of the Ford of the wind industry, just building as many turbines as they could and putting up farms with, a couple thousand turbines, trying to just gain efficiencies through economies of scale. And that was a different approach. Like the Danish approach had been more build really, really sturdy machines that are going to, last 30 years. And they were and then they had a lot of government support. So they didn't have to be as cost effective. But in the US, there really wasn't a lot of government support. So the idea was, well, we're just going to build it as inexpensively as we can and, make it as reliable as it needs to be, but not more than that. So there's kind of a different philosophy there.
And all the while learning as they do it, I assume.
Yeah, like when I started there, and again, I was there to help with blade design. Here's a kind of an analogy of the difference between, say, a rotorcraft, like a helicopter, and a wind turbine. They both have rotors that go around and they have to, fly around or exist in the world, in the wind, whatever the nature throws at it. Well, you can pick when you fly that thing in the wind. You don't fly it in a hurricane,
sure,
if you can help it. And you also fly it for a few hours, you bring it down, you get a mechanic to look at it. So the number of hours per hour of maintenance is, not that many hours. For a wind turbine, you want to build that thing, stick it out in the world, wherever you put it, you plant it. It has to take whatever Mother Nature throws at it, 7 days a week, 365 days a year. And you want to only visit that thing at the most twice a year if you possibly can, because every time you send somebody out there, that's cost you money. So it's kind of almost the other end of the spectrum in terms of what's required of this thing that you put out there. It just has to be super, super reliable. And so that was a big part of the work that I was helping with when I was at that OEM company, is trying to understand all the different conditions that the thing has to survive under and make sure that those conditions were taken into account in the design.
That's fascinating. And I know, depending on where in the world you're putting this, the conditions could be tremendously different, right? You're probably talking temperature. You're probably talking, I assume wind speeds are probably not something you look at, because I would assume you can be ready for any wind speed no matter where.
Well, yes, but what you do need is you need to know the history in every location. So even though, yes, you design it to make sure it can handle, the wind speed is say for an operating turbine, you can operate it up to maybe 55 miles per hour. That's like 25 meters per second. That's 60 miles an hour. And then if the wind is stronger than that, you actually shut it down. And you might think, well, that's silly. Why would you do that? And that's because the higher the winds get, the higher the loading is on the turbine. And even though, yes, you could still produce electricity if the winds are 100 miles an hour or something like that, but the amount of loads you have to withstand are much higher. And you have so few hours at that type of high wind speed, it's not cost effective to design it to withstand all those loads if there's only a few hours a year. So there's a lot of strategy that goes into the design. Even the size of rotor that you would pick for a specific location, you have to know the daily variations in wind speed, the monthly variations, and the annual variations. Ideally, you have to have at least 1 year, full year of data at a site before you would even know what turbine to pick to put there. Ideally, you have multiple years of data. But you're right, it's really important to match the turbine model and rotor size and power rating and all that with the location. And temperature matters. There's variations of machines for high temperature areas. There's variations for low temperature areas. Like, do you remember a few years ago, Texas had a huge, really weird freeze? that came through.
Yeah, and it shut down their own personal grid, right?
Yeah, they got completely shut down. And the wind farms, Texas has a lot of wind farms. People don't necessarily know that, but I think it's got the second highest number of wind turbines of any state in the country. And some of those projects did shut down as a result of the low temperatures. Well, anyway, there's a whole history about that event that happened that's really fascinating. But those turbines were not designed for low temperatures because
Right.
Texas, I mean, who would have thought?
Sure.
So some people were kind of making comments about the wind turbines failing, but it was like, well, the design wasn't intended for that type of weather condition.
So I guess with the Earth changing these days, you got to take more variables into consideration, I assume?
Absolutely.
Yeah.
So onshore projects are usually designed to last about 20 to 25 years. Sometimes they can operate longer than that if the equipment's still operating fine. Offshore projects are typically 30-year project life. And yeah, more and more. That was another thing that we've been doing more and more in my team at DNV is designing for the potential impacts of climate change. So because the climate is evolving and things like hurricanes are getting stronger and flooding events are getting more frequent and also more intense. And so those things need to be taken into account when you're siting the turbines out in the ocean, and also when you're siting the substation or whatever, the electrical equipment that's back on land. You want to make sure that that's going to be in an area that's not going to be impacted between now and 30 years from now. And there's a lot of uncertainty in those calculations, but you can't ignore them. There's uncertainty, but there's not unknowledge. That's not a word. There's not a lack of knowledge about what's happening. The uncertainty is more around the extent of things. And it also depends on how effectively and how quickly we're addressing the sources of climate change to start to bend that curve down.
Lotsofmaps.com. Vintage, local, national, and world maps for an affordable price. 99% of our maps are $25 or less. Great as gifts. Frame them or put them under glass for your home, vacation home, or as a memory of a special place. Lotsofmaps.com.
Okay, Ruth. So you're at Kennetech. Did you leave there before? You said that they went bankrupt. Did you leave before they went bankrupt?
No. I was part of the company when they brought us all in. I think we were a few hundred people by that point. Brought us all into the manufacturing floor, and we got the news that they were filing Chapter 11.
Wow.
It's kind of not that uncommon in the wind industry. It was just a weird confluence of forces that led to that. But no, it was pretty surprising, and we were sad about it. So
Yeah.
and I had just gotten married, so I was about 4 months into being married, newlywed. At the time, my husband was working at a little startup company that had no funding whatsoever. So that was a great way to start our marriage together.
Actually,
but it all worked out.
And you were working for a company that had no funding either.
That's right. well, we were all let go. So I had no job.
Oh man. Okay. So did they let you go immediately, or what happened there?
They did. They let almost everybody go.
Yeah.
I ended up getting a few months contract, a project that we had been working with one of the national labs that still had funding, and I got to finish that out. But it was really weird. I would drive to the big building, and there were probably 4 or 5 of us in the building, and I was just by myself working on this little research project for a few months.
Wow.
But anyway, that kept going. And then within the next year, I got hired by a little consulting company a little bit after that, also in wind energy consulting. And then we moved up to Washington State, where I live now. That was all down in California, where I was initially working. And then I actually left the wind industry. I was kind of disillusioned, as you might imagine, by that, and feeling like, gosh, the issues are no longer really technological. It seemed more like a policy challenge. And so I decided to go back to graduate school and get another master's degree in something called industrial ecology. But the University of Washington didn't have a program in that particular field. They had one professor who was kind of doing some related type of things. Industrial ecology is like the design where you're trying to design waste out of the system. So it's kind of like another level of thought process in the design. And it's quite common nowadays, but this was back because this was 1997, 98 timeframe. It was a really brand new field. So I ended up in the forestry department because that's where this professor was. And I learned a lot about forest ecology for about a year, which was also quite interesting, but a little bit of a, tangent. Then I was pregnant with my daughter. And so I left the program when she came along. And a year after that, I was trying to decide whether to jump back into that or what. And then turned out we were pregnant again. So anyway, we had our son came along. And then I was a full-time mom. I just completely exited out of the workforce and did that for about 6 years. And
that must have been your most challenging role. Clearly, that is
totally.
Yeah, right.
It was because I think I'd worked about 13 years up to that point, all in pretty heads down engineering stuff. And then these kids came along, and I really embraced the full-time parent role. I loved it. I did a lot more cooking than I had ever done before. And we had, a pretty active neighborhood babysitting co-op. So we got to know all the other moms in the neighborhood, and we'd swap our kids around. And then when our kids were in preschool, we picked a co-op preschool where the parents were, helping to run the classes. So I was very much hands-on. We also joined one of those CSA community agriculture programs where you go to the farm and gather up your week of vegetables. And that was a great way to help the kids understand like where food came from and all the different animals and things they had. It was a full service farm. That was so wonderful. And there were a bunch of moms with kids that we would all meet out there once a week. And actually what spurred me to get back into the workforce, obviously the kids are, my daughter started kindergarten, and then our son was a couple of years behind that. And I knew I wanted to go back to work. But, from a technical field, you leave it for a while, and there's kind of a conventional wisdom that, well, it's going to be really tough to get back into it. And I really had not been sort of keeping up on the side. I mean, that you say parenting, it's the hardest job, and I think that's totally true. And I didn't have the bandwidth to, even read technical articles or things while I was full-time home with the kids.
Absolutely.
By that point, though, I was rethinking getting back into wind energy, partly because I had a lot of experience in it and I really did enjoy it. And the other thing was my husband and I had always wanted to live abroad for at least, a year or something and just try that out. And so I thought, getting back into wind might present that opportunity because it's a really, there's a lot of stuff going on in Europe. And we had decided at that point specifically that we would like to live abroad in Denmark. So that was a plan that I had with no plan on how to execute that. But I reached out to my network, and I had been before when I'd been in wind, I'd become friends with this. There were not as many, obviously engineering, there's even today, it's more male dominated. It was more so back then. And I had made friends with this woman in the early days when I was involved in wind energy. We would run into each other at conferences and things like that. And she was running a consulting company in Seattle. And we had kind of loosely stayed in touch. So when I reached out to her saying that I'd like to come back to work part-time, I didn't want to go full-time at that point with my husband really deeply involved at Microsoft. And she said, okay. And I, that was kind of, again, these days, there's a lot more part-time type of roles available. And that was unusual at the time. I think I was the first person that she okayed that for. But one of the things that was an advantage is it happened to be a time when the wind industry was really cranking. They were hiring or trying to hire a lot. And when I joined, I think I think it was the 48th person at the consulting company. And within a year, we had expanded to like 100.
Wow.
So very, very rapid growth. When she hired me, the first thing I said was, hey, by the way, my husband and I are really interested in living in Denmark for maybe a year or so. And so, just want to let you know. And I was kind of thinking like there might be some opportunities with the different kinds of projects that the company worked for that would be in Europe or maybe even in Denmark. And she kind of looked at me blankly and she said, okay, that's nice to know, but sort of like turned out, no, they didn't really have any big projects or things going on. They had, the US there was so much demand in the US that was where most of the work was.
Sure.
So, okay, I had put it out there, but I kind of let it drop. And that was in 2006 is when I went back to work. And Don and I had already kind of scoped out the year we wanted to go abroad. We wanted it to be our daughter's year of fourth grade and just go for a year and then come back. And then she'd have fifth grade in the same school that she had been in, and it would be easy to kind of matriculate back in.
Mm-hmm.
So that was our vision, but no specific plan on that. So time was going on. So two things here. One is just getting back into the technical work. I joined the turbine engineering team, and it was the strength of my analysis background that I'd had from my previous work, both at NASA and at Kinetech, that they recognized. And I think probably the fact that my friend was the CEO of the company, that on her recommendation, this team of all men was willing to give it a shot, have this, me coming back after 5 years or 6 years of being off the technical work. But I dove right back in doing the loads analysis type of work and support for different companies that would come to us for help. I'm sure on some level, when you take a big time out of work for being a full-time parent or whatever, there's probably some change of path that happens there. Maybe there's some title that I might have achieved or something differently than I did now. But I'll say that those 6 years off were super enriching to me personally and with my kids. And then going back and being able to dive into the technical role. I mean, I started off as a senior engineer and just was able to come back and, again, be writing technical papers and working for the government labs, with different projects that we would partner with them on. I'd say, holding my own technically, and that was very rewarding. And something I do try to share with other women engineers who are thinking about families and the younger ones that are coming in and trying to figure out how to navigate all that stuff. I went to a conference once, and the head of, at the time it was called the American Solar Energy Society, happened to be a woman, and she was giving a talk. She said something that really resonated with me, and she said, women can have it all, but you don't have to have it all at the same time.
Right.
And she had said that to me even a little bit later than this in my career, where I had already taken that time off and come back, and ended up, we did go to Denmark, and I worked, well, actually, what happened was, so I got back into the technical stuff, really enjoying that, but also we were still going to do the Denmark thing. We were actually going to do that whether we could find a job with it or not. That was our plan. And what happened was, maybe 8 or 9 months before our plan to do this, Don came home from Microsoft, and he said, guess what? His team at Microsoft had just bought a Danish software company. I was like, wow, that's amazing. Shortly after that, I think he told his boss that he was going to leave Microsoft because we wanted to go and live in Denmark for the year. And the boss said, well, why don't you not leave, and you can stay with them with Microsoft, and you can work for Microsoft in Denmark. And so then that was kind of cool. And then they would pay to help us get visas and things like that. So that was amazing.
Wow.
We were just like, okay, there's like this path to get there. And then a month or so after that, I was really psyched, but I was also a little disappointed, thinking, gosh, I'm the one who wanted to go there for my career, and it's great that we're going to get there, but I wish I had something I could be doing there. And I was sitting in a meeting in my company, which, because it had grown so quickly, it had become an acquisition target. So the CEO and the president were going around and meeting with potential buyers, unbeknownst to us. the rest of the company. And they came in and they said, and we, most of them, they just were not a good fit, but we found this one company that's interested in buying us, and they are headquartered in Norway. They're DNV, this is the company that I work for, but they have one wind energy office, and it's in Copenhagen, Denmark. And I could not believe it. I was sitting there going, oh my gosh, this is insane. It wasn't a done deal yet, but they were moving forward with it. I went straight to the CEO's office and I told her, hey, remember I said that thing about wanting to work in Denmark? I mean, I told her that Don and I were already planning to go no matter what. And I said, maybe there's something I could be helpful, in this transition if this goes through, whatever. And so she kind of stuck that in her back of her mind or whatever. And that's what happened. I was the first person from our company to go over there. And then they had sent a few people over to Seattle, and working there for a year and helping to facilitate, connecting people from the office there to our office in Seattle, and then learning a whole new side of the wind industry. That's actually where I got into offshore wind first, because they were already doing that. That was in 2008 and 9 is the year that we were there.
Talk about having winds going in your favor.
Oh my gosh, it was totally the tail wagging the dog situation. We could not believe it. We could not have planned it. And it's really unusual to have, we met other expat families over there from the United States or from other countries. And usually it's only one spouse that gets to work, because once you're there, there's a lot of restrictions on what they can do. But we already had these two roles. That was super, super fun, interesting, again, continuing to be challenging. I was working on certifying offshore wind projects. So that involved a lot of analysis to make sure what you're doing there is you're analyzing the turbine from the company that's making it, doing all the analysis on the computer, putting it through all the different kinds of environments, winds and waves and whatever that it can experience. Including things like marine growth. You don't think of that, but that adds a lot of weight to the foundation, and it has to be taken into account in the design.
Sure.
So just, learning a lot about the whole industry over there. And then when I came back, I was still with the same company. And at that point, I was really eager to go back to work full-time. I had been part-time, kind of gradually inching up, but I had been part-time for those first couple of years.
Mm-hmm.
But I really wanted to go full-time. And Don, he had been at Microsoft by then about 12 years, and he was totally ready to just say, see you later. He'd had enough, he'd had some good times there too, but he was in a group that he was not really happy about at that moment. So he got to be a full-time dad.
Hey, how about that?
And trade roles there. And so he did that for a couple of years. To the point where eventually I was like, so are you retired at this point? Because he was really enjoying that. And then he ended up also, going back to work, but not he went to work for the University of Washington and did some other stuff. Or now he's doing a little startup. So I stayed with this consulting company until 2014. And again, doing the same type of work that we've already been talking about. But then my career took another kind of totally out of the blue shift. Well, I went independent for a little while. I became an independent consultant, and that was to have a little more flexibility in my schedule at the time. That was the time of when my kids were really involved in a lot of activities and not old enough to drive themselves anywhere. So I wanted a little more flexibility there. After about a year of doing that, I was contacted by my former manager from way back when I worked at NASA. And he and his wife, we had stayed together. And maybe this is another sort of plug for, I'm not the best networker by any means, but just, staying in touch with people who have meant a lot in your life or made a big difference. And
Sure.
He was a really great first manager manager to have. And we had just kind of stayed in touch. And so he had been hired by Google to head up their, they had they're a software company, but they had one project that was going on that was a wind turbine a very unusual kind of wind turbine. In fact, it was called a wind energy kite. And that is where, basically if you broke off one of the rotor blades and tied a string to it, down to the ground and let it fly around in circles, you can conceivably generate power from that. You can put rotors on it and send electricity down the tether down to the ground, which is what they were trying to do. And he'd been hired to head up that project, and he wanted me to come and help with evolving it from a concept or a prototype into something that could be manufactured and multiplied.
Well, let's talk about this kite. Tell me what the advantages of that are versus the turbine. Great
question. And this is why I ended up joining onto this project, because of the possibilities. So this kind of ties into the topic of climate change in the big picture, or just kind of like, how do you reduce your impact on the world in a sense, or any kind of negative impact, I should say. We want to maximize good impact, positive impacts. But everything that we do, that we make or build or whatever, we're having some kind of impact on, I guess, say, nature. As a humanity, we're all becoming more aware of this. We have to start looking at our planet as more of a spaceship than an infinite source of infinite supply of everything.
Sure.
Some things are quote unquote infinite supply, like sun, and maybe wind is in that category. But other things like the number of trees or, the clean water. I mean, there's, we're with the number of people that we have on the planet, we have to shepherd all those things pretty carefully to make sure that we maintain the health of the planet. So this idea of a kite, of generating wind power by flying some hardware up in the sky and then bringing the electricity down through a, kind of a skinny tether, attracted me, because the theory is that you could generate similar amounts of electricity with 90% less material overall. So that was like the overarching, like, what's the value proposition here? If it works, you could conceivably generate electricity, and you wouldn't need that big tall tower. You wouldn't need the big hub that's in the middle of the tower, and you've got all the, these big long blades going out from the hub and all that stuff. Basically, what's capturing the energy from the wind is the blades themselves. And in fact, it's not even the whole blade. I'd say the outer 50% length of the blade is getting about 80% of the power out of that wind. Of the amount of power that you're extracting, 80% of it is from the outer half of the blade. So if you just theoretically just cut that blade in half, take that half, fly it around in the same configuration that it flies when it's attached to a rotor, roughly, and skip all that other stuff, then you could potentially, so that you're using a lot less material. Now it's more sophisticated material, so it's not going to be 90% less expensive.
Right.
But at least in terms of like the amount of molecules you need to do that, you could potentially do that. That was in 2016 is when I started working there, and was with them until the pandemic hit. And actually, it was right before, like weeks before, maybe even 2 weeks before everything got shut down, our project was canceled. And this kite, if you think about the size of, how big are we talking here? Because everybody's flown a kite when they were a kid. These are big kites. The wingspan of the kite we were making was 28 meters.
Wow.
Which is the same wingspan as a 737 aircraft. So really big, but had a tiny little skinny fuselage, and it had 8 rotors mounted on it. It's a pretty wild looking thing. If anyone's interested, there is an actual documentary movie about it. I'm not bringing this up. I mean, I'm in it for like 30 seconds or something, but it's quite an interesting movie for anyone who's interested in like the engineering process or the invention process. And it's called Pulling Power from the Sky, and it's on YouTube. So if you just went to YouTube and Google Pulling Power from the Sky. You can find that movie.
Excellent. And we'll, if you give me the information, I'll share it with our audience on our Facebook page and things like that. So
Oh, cool.
folks
I'll send you a
can do
link.
that.
Yeah.
Great.
Yeah. It really is a fascinating movie. But in the end, I would never say that airborne wind is not possible. We went pretty far down the road and had a lot of resources. Having Google as the parent company backer or whatever was pretty unusual for a startup type of project in terms of amount of resources that they
Sure.
could put into it. But we ended up testing this, pretty large kite. It's all made of carbon fiber, really high-end materials in the North Sea off the coast of Norway on a floating buoy, basically. And we demonstrated that it could fly and it could launch and land and fly loops and generate electricity. We also flew it a bunch of times in different ones in Hawaii on the Big Island. So we did test it out, but I would estimate it would need at least another like 10 years of development to really prove out the concept, even if it's to prove whether it's even feasible or possible to do what we were trying to do. So
Is that
it was
continuing to this day or no?
not the Google project. No, it was called, the Google project was called Makani. We actually ended up becoming, for 1 year, we were our own company called Makani Technologies, I think. Well, there's one company in the United States that's still pursuing airborne wind that I'm aware of, and maybe about 8 or 9 in Europe that are trying different ways of doing it. The challenge is that you're fighting, not just fighting the wind. The wind beats up turbines and things pretty handily, but you're also fighting gravity every time. To keep something airborne, you've got to fight against gravity. And
Sure.
again, theoretically, seems like it should be possible. On paper, there was some analysis that showed it was possible, but really getting it to work in all the winds that it needs to, it was difficult.
Very, very interesting. And so there's still a possibility that may continue. I mean, it sounds like this company's working on that, and obviously I'm sure your work has been done not for no reason. I'm sure there were other things that you discovered along the way, I would assume.
Yeah, for sure. And another nice thing about, even after the project was canceled and the company closed, Alphabet was the parent company of Makani, but they approved and allowed all of the IP, the patents and everything to be published. And it's all in the public domain.
Wow, great.
Now anybody can go to, if you Google the words Google and Makani, or either way, you'll probably run into and I'll send you a link to that too.
Sure.
Because as much as possible, the lessons that were learned, there was a team, sort of a core team of 4 or 5 people that stayed for another 6 months and just documented as much as possible what was learned, so that if somebody else has a few $100 million, then they might be able to resurrect some of it or learn from it and take it the next steps.
Well, here at Occupations, we're doing quite well. So we might
awesome.
have those kind of funds to continue and maybe have a kite, the Occupations kite.
Yes, there we go.
That would be lovely.
Yeah, for sure. My role at Makani for that project, I led the systems and product team there. And my first goal I was given was to help build a certification program for the kite. Any kind of a wind generator has to be certified, or it won't. No one will buy it. But actually, we realized shortly after I got hired there that we weren't quite ready for that stage. So anyway, we spent quite a lot of time developing a systems model of the whole kite that was used to help with understanding its operation better, and also trying to work out improvements to the design. So that was a really interesting role to have, and really, really interesting team.
Sure.
Wonderful teammates there too.
That's great.
Yeah.
So once that project was canceled and the pandemic came along, where did that put you?
We were all given kind of a soft landing, which was, again, very generous of Google. So I had several months to kind of look around and work with career support type folks at the company. And I was, again, thinking what would be my next steps. I wanted to, for sure, stay in the field of either renewable energies or the kinds of roles, where companies are working towards more sustainability, more sustainable practices, that type of thing. So I looked around some in that direction, but I had been exposed again to offshore wind at Makani, and the idea of seeing that this new industry of offshore wind was starting to come up here in the United States. A bunch of areas off the east coast of the Atlantic coast had been leased from the U.S. government. This is in the outer continental shelf regions that are more than 3 miles offshore. That's all U.S. government or federal government jurisdiction.
Mm-hmm.
But all these areas had been leased. And so, thinking about how could I support the industry growth? I mean, here I am by this point, almost 30 years, 28, 30 years into my career, and seeing the potential for the U.S. to build a new industry. That opportunity, well, I guess what I've been seeing is something that happened, in the early or mid 1990s when I first joined the wind industry. That was kind of the first iteration of it becoming from like a boutique kind of fringe industry to mainstream for onshore wind turbines. And I was, right in the thick of the industry transition for that in that period. And now I was seeing, this is in, 2000, we are still now even in the cusp of bringing an industry into the United States with this offshore wind. So when it kind of clarified that I really wanted to be supporting that, I reached back out to DNV, where I had the consulting company where I had worked before,
Mm-hmm.
the one where I'd gone to Denmark and all that. And their offshore wind team was hiring. So I just came right back on board, and new team, but I knew the company and had kind of peripherally stayed in touch as well, even when I was working at Makani. So it was a very easy fit to come back and support those projects. So I did that up until July 5th of this year. And I know so far the interview, it might sound like I'm still doing that, but actually I retired in
Hey,
July.
congratulations.
Yeah, thank you very much. Yeah, it was, I think pretty much almost to the day that we're doing this interview, which is middle of August, is with the 39 years since I, first started my engineering career. So
Wow, what a great career.
feels like a good time to move on. But going back to DNV, but into the offshore, that was, there's quite a lot of new aspects to that, much more complex than the onshore piece, because you've got all the maritime working
Right.
in the water, and there's a lot of environmental studies that need to be done for onshore projects, but you kind of multiply that by pretty much an order of magnitude with what's demanded for offshore. And it's not just environmental, it's archaeological, and you even have to know where there's unexploded ordnance and things like that. There's and then of course geotechnical challenges with the seabed and the benthic, the condition of life at the bottom of the ocean, and all those factors have to be taken into account. Lots of studies are done before anything goes in the water that gives kind of a baseline. And if you look at the projects in Europe, some of them have been in operation for 2 decades now. And so they've got a kind of history, even though, of course, conditions are a little different on our East Coast than they are in the North Sea. But at the same time, there are lessons being learned there that are valuable for the project development here in the U.S.
All right, so we've got your work history, obviously an unbelievable career. I'm sure looking back at it and listening to yourself on this interview, you probably realize how much of a whirlwind career you've had. But boy, you've dropped some pretty big names there, and you certainly have worked on some very important projects for sure. That has, no pun intended, propelled the industry forward.
Yeah.
Let's talk a little bit about working in an all boys club. I mean, that's
Yeah.
You're sort of a pioneer in some regards, I'm sure, in that industry, and that can't be easy.
Yeah.
Now, I know that the reason why this is probably male dominated is because males blow a lot of hot air, and thus, thus we're probably very good at that. But how tough was that to navigate?
Yeah, that's a great question. You know my family to some extent, so you know that I'm the only daughter and I have 4 brothers. So I grew up in a pretty male-dominated household. So in that respect, I wasn't intimidated by going to, when I started college, MIT was 23% women. The graduate was much less than that. And now I think it is roughly 50-50 at this point.
Yeah.
So it was noticeable in the classrooms. I happened to have a great living situation. I lived in a house with about 50 students, and it was kind of artificially maintained at roughly even, men and women. So in that sense, there was some nice balance in my living situation, which was great. There were things that were very intimidating about being at MIT that I don't know if that was related to the male-dominated part or just the reputation of the institute. But I had, like in high school and stuff, I'd always felt like, I was, obviously a decent student, and I did drama, and I was involved in various extracurriculars, and standing up in front of people and talking never intimidated me. But when I got to MIT, I was extremely intimidated. Like I think I was a senior before I had to actually stand up in front of anybody and speak, and it was a catastrophe pretty much, and something that I had to work on when I got hired and stuff, or when I went to work for NASA. And I mentioned earlier that that boss at NASA, who I then subsequently worked for as well, he was so patient and helpful in helping me get over that kind of stage fright. You had to do presentations and present at conferences and things as a matter of course. And it was, how people talk about the fear of public speaking
Sure.
being like worse than being shot or something. And I think I had that. But anyway, he really forced me to practice over and over, and it really helped me to get over that.
Well, and I imagine,
so I've had supportive.
I'm sorry, and I know we're talking about male intimidation and working in that, but just talking about MIT, NASA, Stanford, these are incredible. Google, you're talking about just being intimidated in total. Never mind being a woman in a man's game.
Yeah.
So to navigate
I'll
both
tell you,
of those
I've
things.
I've never ever feel like I've gained mastery. I'll just tell you right there. In any realm. I've worked hard, and I suppose I've done some things, but there's always something or someone out there that keeps you humble. The NASA experience was really great. And again, like I've had, different bosses and things that have been, mostly I've had male bosses, some very enlightened and supportive, like that first one. And then I've also had female bosses 2 times in my career, and that was wonderful and different. So I'm, sort of jumping around and thinking about that, working in a male-dominated field. I think, again, because I had grown up with all these brothers, I had a certain level of just sort of awareness of boy energy, or whatever you want to call it. I never encountered like overt sexism. I had one aircraft mechanic at NASA. I went to go and ask him for something, and I was probably 2 years into my career. So what am I, 24 or something? And he's probably, easily old enough to be my dad. And he just ended his response to me by calling me babe, just so like, oh, okay, I'll be happy to get on that, babe, or something like that, kind of off the cuff. And I just stared at him and I said, I'm not your babe.
Wow.
And he was immediately just, oh, I'm so sorry. I didn't mean anything by it, and he was very apologetic. So, I was willing to stand up for myself.
Yeah. Were you expecting that? Do you think you were preparing yourself for some of that?
Yeah, potentially, I guess. And I would say, like, among my colleagues, this is over a 39-year career working with far more men than women. I never felt directly discriminated against or anything overt. there were times, like when I was at Google, they were losing a lot of women, mid-career women or middle management women. And so I was considered, because of the role I had, I was managing a team, and so I was considered in this middle management role. And they actually had this year-long women's leadership training program for people like me, and which I did. And my boss, who again had been my boss previously at NASA, he was super supportive of that program, and it was really a great opportunity. So, I think there's still a need to foster conditions that are just more supportive and I wouldn't say just women, but diversity in general.
Yeah.
And it's not just like a favor to do for the industry kind of thing. That's something I really think strongly about. It's because the kinds of problems that we're trying to solve in the world today need the best thinking from all dimensions. And the standard nerd, if anyone sort of conjures up their standard concept of a nerd, they're going to have a certain look to them. And it's probably going to be a male look. But we need ideas from different cultural backgrounds, different genders, we need all the ideas, or we aren't going to really be solving the problems.
Women are nerds too, you know.
Absolutely. I take that as a badge of honor.
I'm glad to hear that you didn't really go through too much of a hassle, but I'm sure you were respected for your work ethic and everything else on top of it all. So I'm sure that probably intimidated a lot of guys out there too. So hopefully they behaved themselves because of your work ethic and who you were. And
I'm, and maybe I just got lucky too. And also I would say that I think the industry that I've been in, it attracts a certain kind of person. Renewable energy, whether we're achieving it or not, we're in it because we see a need for some change, and we think that this is the best next step. I would never say it's the whole world should be run on wind turbines. I mean, it's just the kind of thing that we should be using where it makes sense. It's like we need diversity in our energy mix, and in all the climate change solutions. We need all kinds of creativity in our thought process. The one thing that's gotten stronger for me over the years, as I've grown, gotten more mature in my career, is reaching out more to younger women in the field and mentoring. I've done a fair amount of mentoring, both at Makani and then back, coming back to DND for women who are just coming into it, and just helping them to grow in their careers, or see the possibilities for themselves.
Well, that makes a lot of sense because I look at you as a pioneer. I don't know your industry, but to listen to the path that you took, you clearly were doing things that not many people, never mind women, anybody was doing. And boy, I would imagine that girls and young women probably would love to look up to you.
Yeah, I mean, if there's anything that I can share, that's something I'd like to do in my retirement. I'm pretty freshly retired at this point, so I haven't, I don't have a good plan there. But that's a high priority right there. That and just education in general, or really encouraging kids to explore their curiosities. I think there's a lot of need for, and also opportunity for, new and better ideas to be developed.
This is going to be probably tough to answer because you've had so many different positions or different types of projects to work at. But what was a typical day in Ruth's work career? I mean, it sounds like you went on site a fair amount. Is there a typical day in what you do?
Yeah, let's see. So I'll do a typical NASA day, a typical Kenetech day, and then a typical consulting day.
Sure.
Those are maybe 3 chunks.
Okay.
The NASA day, if I had a test going on in the wind tunnel, before I left there, I was able to be test director of a couple of tests. So in that role, you're in charge of all the, just the planning of the test. You're making sure that the test article, whatever it is that you're testing. So the last test I was worked on was the testing, the tilt rotor aircraft. It's kind of it flies like an airplane, but
Oh,
then
and
it
it
can
lands
tilt
like
the
a
rotors
helicopter.
and it lands like a helicopter.
Yeah.
That. So we were doing testing, some basic aerodynamic testing and loads testing of that in this 40 by 80 foot wind tunnel. And so we had to build, test stand components for that. And so we have a machine shop on site. And so I'd be going over there with drawings, and I was not drafting the components. We'd have a structural engineering department that was doing that, but I'd be overseeing that, overseeing the loads analysis to make sure it's not going to fall down, making sure it's getting installed properly in the tunnel. And then when we're running the test, then, you're sitting there in the test, the command center, whatever, it's got like windows and screens and stuff that are keeping tabs on the test article, and, just making sure that it's all, as a test engineer, I'm just sort of managing the process, but I'm not running the machines and all that.
Right.
I had a
But you're
team that
certainly
was doing that.
observing, right?
Oh yeah, observing everything, and then primarily, collecting all this data, and then the data that we'd have, that would be my job to go through it and compare it with the computer analysis codes, or use it to validate the computer codes, things like that. So my day would be, probably half sitting in my office in front of a computer, doing various things, and then half the day in the test facility itself, running the test, something like that. There were times I was doing some acoustic testing at one point, and we could only do it when it was as quiet as possible outside. And so we would run the tests at like 4 a.m. in the morning. And I would be,
that must have been
when
fun.
That was fun, especially because I didn't have a car at the time. When I first moved out there, I didn't have a car. So I would bike to work every day, which was, it's California. It's usually pretty good weather. I think it was like 8 or 10 miles or something each way. But I'd be biking to work at 3 a.m. in the morning.
Wow.
The NASA Ames Research Center is the place where the space shuttle pilots practice. They do their flight simulator is there. Oh man, that was fun to go and watch. You could go and sit in like this visitor room, and they'd have a video showing the flight simulator module. So it's like it can go up and down, 5 or 6 stories at a time, and like, they're simulating like 5G or whatever it is. And it's rolling and pitching and translating. And then you see what they're seeing. Like you see them trying to come in and land the thing, or whatever they're doing. That was really neat. So just being at the Ames Research Center, it lent itself to a lot of cool opportunities.
That's great.
Okay. And then Kenetech was also, again, I was mostly doing analysis, but I'd go and climb turbines once in a while. I wasn't a test engineer. So those are the people who are out there, day after day, instrumenting the turbine and measuring stuff and flying it and taking data. I would just be using their data, and again, in our analysis, to either try to make our tools better or developing tools to better predict how the turbine is going to behave.
Okay.
So most of my job there was at my desk, at my computer. But I also got to go to a lot of conferences, and I'd write, present research results or things that we had learned, stuff like that. I enjoyed that a lot.
Sure.
And then at DNV, so this is consulting again. There are test teams there where they're very much out in the field. But I was, again, on a team that was mainly doing analysis. So when I first joined there, I was with the turbine engineering team, as I mentioned earlier. And I jokingly called that the child psychologists of the wind industry, because basically, like, there's a turbine that fails, a blade breaks, or the generator or the gearbox seizes up, or something like that happens. Then they hire us to come and try to understand, do the forensics and try to understand what's the root cause, what happened, and then feed that back to the manufacturer so that they can improve their design. The reason why I thought of it as the child psychologist is that when you're doing that kind of work, all you're seeing are the problems. It's sort of like, what is the child psychologist's view of childhood is probably skewed by the fact that only people come to them when they're kids having a problem.
Right,
So
of course. Well,
I don't know.
and I
It's
imagine
interesting.
it's probably devastating to see a test fail after spending so much time on it. Although I'm sure you're going to learn from that, but I imagine putting so much work into something and then seeing it not come to the result that you ultimately want. That's got to be tough, is it not?
Yeah, for sure. And actually, there's two sort of things going on here. Like, one is when you designing a test to learn something specific, and then, yeah, if it fails in a sense that you didn't expect, or especially if it fails because you just missed the boat on something, that's a bummer. But sometimes failure is very instructive.
Sure.
And then you certainly can learn. And that was more the case, like with the Makani testing was much more about like, we have to try to understand how this thing is operating, or, what we can do to make it better. And then there's like turbines that are already in manufacturing, and they get put out in the field and they operate for 5 years, and then something breaks, but it was supposed to last 20 years.
Mm,
Let's say the blade breaks. And that's what I was more talking about on the sort of child psychologist side of
yeah.
things, or like when the company will come and say, gosh, this blade was supposed to last much longer. What happened? And, you go through and you're looking at pieces of it and try to figure out like what failed first. And was there a manufacturing defect? Was there, just a crack that opened up because, something got damaged when it was installed, things like that. I guess, that's one thing as an engineer, you're just taught to sort of learn no matter what, like whatever the circumstance is, it can look like a failure, but really, isn't it Nelson Mandela line where he says something like, I win or I learn,
Mm,
or when you don't win, you're still going to get something out of it.
absolutely. But
But
still,
it
it can't
was
be
really
fun.
hard to, yeah,
Yeah.
when you see anyone who watches that Pulling Power from the Sky documentary will feel the pain of failure. we,
All right.
there's many
Yeah. I'm
opportunities
sure
to
that's got to be
experience
hard.
that. Yeah.
Stupid question. Okay, so you climb one of these things and it's 4
Hmm.
bazillion miles into the sky and
Yep.
you get to the top and you're so exhausted you can't think how you're supposed to work.
Yeah, that's a great question.
I get
So
winded just going up one flight of stairs, so I can imagine that's a
yeah,
problem.
it's definitely the Stairmaster job for sure. So the initial turbines I was climbing were on towers that were 80 feet up in the air,
Hmm.
or 100 feet maybe at most. And even that, that's a fair amount of stories climbing up, and your forearms get really tired. These days, the towers are 80 meters at minimum
Wow.
tall, or up to 120 meters tall. They have elevators.
Ah,
Yeah. So
that's
now
cheating.
they also they also have ladders too, because your elevators might not work.
Sure.
Then they also have some kind of lift assist. So first of all, safety is a huge issue with wind, no matter what, onshore, offshore, whatever. And it has massively improved since I first started in the industry. Wind technicians back in the 90s were called windsmiths. You have a harness and you're locked in as you're going to climb the tower. Back in those days, not everybody would rigorously climb a lock in to their fall arrest thing. And the
Sure.
fall arrest is basically like, it's like a one-way ratchet kind of, so you can walk up the ladder, but if you let go of it completely, it'll just catch you within a
Hmm.
foot, just stop you.
Right. Right.
We had a guy, one of the workers at one of the projects in another state, who climbed up a tower and was not hooked in, and he fell from the top to the bottom
Yeah.
and he died,
Oh,
which is an absolute
jeez.
tragedy. Nowadays, the mitigations are, number one, there's massively more training about how you don't cut corners, you don't
Yeah.
rush through things, you do things safely,
Sure.
you lock in. In addition to that, at every probably 20 meters, there's a platform, so that it would limit how far you could possibly fall.
Got it.
Um,
Got it.
and there's, that's just a tiny, tiny hint of the that,
Sure.
there's just been a lot more attention paid to safety.
Yeah.
I did climb an 80-meter tower without an elevator myself once. And I will tell you, my forearms, I felt like I couldn't even close my hands.
Wow.
And I did somehow get myself down from there too.
Huh.
So,
And how
yeah,
do
it
you
was real,
think? I mean,
real time.
obviously, I mean, do you train for something like that, or is it you just did it,
No,
and now
and
I'm
in fact,
supposed to get up there and I'm supposed to think hard and try to figure out something that what I went up here to do in the first place.
yeah,
But my entire
exactly.
body is throbbing right now, and it's hard for me to think. How do you do that?
The tower that I climbed, I didn't have any particular fall training or anything like that because it was even in 2008 that wasn't required. Now that stuff's required. But my boss was like, "Hey, you want to go climb a turbine?" I'm like, "Of course." It had been like 10 years since
How
I'd climbed a
cool.
turbine. And so we drove out to Eastern Washington and yeah, climbed up this tower. And yeah, no, nobody asked me, do I have any health issues or, do I whatever? And I didn't have,
Afraid
I
of
mean,
heights,
I've
maybe?
always, yeah, I mean, I'm not, I was totally gung ho. I love I have to say, being up at the top of a turbine and usually, well, the onshore ones that I'd climbed, the top part, the fiberglass shell, it opens up. And then you're just looking up at the sky and these giant blades, and it's, and you can see everywhere around you. It's really cool.
That's
It's
amazing.
really cool. It's outdoor work. It's, yeah, a lot of physical just because of the climbing. Yeah, I guess that's the main thing. But again, the turbines nowadays do have elevators. But all those people who work on the offshore turbines, they also have to have the helicopter rescue training, which is like you have to train as if your helicopter fell into the water and turned upside down. They do this in a swimming pool. They have a fuselage of a helicopter and you're in it. It gets dropped into the water. It flips upside down, and fills with water. And then you have to extract yourself from that without drowning. So
Wow. Yeek.
that's the training for it. Yeah.
Without
It's
drowning.
pretty wild.
Wow.
Right.
So you fail if you drown. Oh
You
man,
fail if you
that's
drown.
not
Well,
good.
they have like scuba divers in the pool with you,
Okay.
so in case you can give a signal and say like, okay, I didn't make it.
Wow.
Lotsofmaps.com. Vintage, local, national, and world maps for an affordable price. 99% of our maps are $25 or less. Great as gifts. Frame them or put them under glass for your home, vacation home, or as a memory of a special place. Lotsofmaps.com.
So Ruth, it sounds like you have a real passion for what it is that you do. You must love your job.
I really do. That is not feigned. I guess the driving motivation for my whole career actually has been, what can I do to be helpful to, we live on this amazing planet that, really does need our support and care and feeding. And so for me, that's been a big driving factor of working in the renewable energy industry. It kind of started off as, just the clean energy side of things, but with the understanding of the impact we're having on the planet in terms of climate change, that's also become a big motivator. And so to me, like every day going to work I'm not doing super fun things all the time. There's certainly drudgery days, but the fact that I believe in the bigger picture and also have been working at a place, DNV, the company itself, its motivating driver is to support the energy transition to make the planet better. So their overarching goal is in line with my values, and that's a huge driver. Even when I've felt sidetracked in my career, kind of talked about how I enjoyed my work at NASA, but it felt like I was sidetracked. But what I learned there was so impactful and helpful for future work that I was doing. And I found that multiple times over my career. So yeah, it's been just a wonderful opportunity to, just learning something new all the time. And, overall, just every day has been, at least the underlying factors have been fun, if not the daily work. There's stressful times and
Yeah, but
that.
I bet at the end of the
Yeah.
day, even on a bad day, I mean, you can come home knowing that you're doing something good, or at least you're attempting to do something good for the earth, and that must make
Yeah,
you feel good.
absolutely.
Do you have any stories about, your industry or something that might happen to you or something, anything fun or funny or ridiculous or serious or?
Yeah, this is a kind of a funny thing that I ran into, years after I'd started working in wind. I was reading a book about the history of the U.S. wind industry itself. It's an example of sort of how far we've come, and even more to this day. And this is kind of on the safety related aspects. And this is a story from back in probably the earlier mid 1980s, very beginning. This is before I got involved. There were lots of wind turbines being installed on the West Coast in particular. And they talk about, and these were a lot smaller than today's wind turbines. But still, you've got this big rotor up there rotating around. And there's a thing that can happen to a rotor if the control system's not working quite right and the blades can't be pitched or, twisted in a way to moderate their speed. They'll get into a condition called runaway, and it'll just be the rotor's just spinning really, really fast if the wind is blowing fast. And there's no way to stop it. If the control system is broken, you have to either wait for the wind to die or for the machine to just kind of tear itself apart. And those
Yikes.
things, that can happen. Yeah. So it's kind of a scary thing. In this story, the way they would kind of corral the rotor would be to send a guy climbing up the tower with a lasso, I'm not kidding, and try to lasso one of the blades.
What?
and grab it before, like I said, these were smaller than a lot smaller turbines they are today, but it's just the notion that, and then as soon as they could lasso the blade and then just kind of keep the rope, I guess it was tied to the tower or something like that, and that would stop the rotor from spinning. But I just thought, wow. I mean, there's so many things wrong with that picture.
Oh my
in terms of safety and.
I was going to say, is this protocol? I mean.
Yeah, no, that is not. And of course, these days the turbines are, even onshore turbines, the sizes of them. I think I mentioned the towers are 180 to 100 meters tall, and the rotor diameters are on the order of 100 meters or more than that.
Right.
And offshore, they're even much larger. But anyway, I just thought, wow, that the industry has really, even by that point, I was probably reading that book in the early 2000s, and I was like, wow, we've come a really long way.
Well, and not only that, you've created a whole new event for rodeo.
Exactly. The turbine wrangling.
Exactly.
Rotor wrangling.
Who knew the two industries were combined in that way? But you're closer than you think you are, I guess.
And a lot of those onshore turbines where are they located? They're out in ranches and
there you go.
Large fields. So the cattle are right out there, so they can wrangle the cattle and they can wrangle the rotor.
So Ruth, how would somebody get involved with, well, becoming an engineer if that's the position that somebody wants? But I imagine there's a whole bunch of different positions in wind, and get involved with making the path. Is there a path to that? And are there other jobs in that industry?
Yeah, that's a good question. So in addition to, being an engineer, which I've kind of touched on already, that's one of the things that is so cool about this industry is there are so many ways one can be involved. Obviously there's technicians that are needed to operate and maintain these wind farms, whether they're onshore or offshore. There's the whole construction and installation phase that's happening. And then there's the environmental compliance. So there's studies that happen before, during, and after projects are installed that involve doing biological studies, marine biology for offshore, looking at endangered species, or all kinds of things that need to get sorted out before you could even install a project, again, whether it's onshore or offshore. There are a lot of community colleges that have like 2-year training programs that include courses on like safety or project management. Some of them have technical skills they'll teach specific to the offshore industry or onshore. A lot of them are on the East Coast right now because of the offshore wind projects that are starting to go in.
Is there like a sister industry where what you're doing could translate into your industry?
Yeah, for the technician work, I'd say, anybody who's involved in, maybe like auto mechanic or fixing machinery of any kind would totally translate to a wind turbine. I mean, a wind turbine has, it's got generators and gearboxes, and it's just components like that are kind of put together, but they're like any other kind of machinery. So anybody who's working in a machine machine-related business, or then if we get to the supply chain, where you're manufacturing these things, there's total transfer of the skills that you would have in any other kind of floor that's building machinery or tools or equipment.
If you did want to become an engineer, is there a particular path that you really need to hone up on? I mean, obviously you got to be pretty good with numbers and things like that, but is there a particular path specifically for the engineering part of what you do?
Yeah, so wind turbines involve, obviously we've got these rotor blades out there. That's kind of like aerodynamics and all that kind of stuff related. So, and that's sort of the path that I took on the technical training side. So I have a degree in mechanical engineering, and then I got a degree in aerospace engineering. But other parts of the turbine, you've got the whole electrical, the power system side of it. So electrical engineering is very germane there. There's obviously these days computer software in every part of the system and the operation of the project. So software engineering, you could enter it from that direction. Civil engineering, in terms of designing the project design overall, that would be more like civil engineering. Structural engineers. So it's kind of a lot of different angles you can come at it from the engineering side. There are colleges that have specific programs for wind energy in general, or even focus on offshore wind, like University of Rhode Island and University of Massachusetts in particular. UMass has had wind energy specific program. I think it's in their mechanical engineering department, but they've had that for decades. So they're really well known. MIT, where I went, doesn't really have a very specific track, but the general education that you would get there, pretty much, yeah. I mean, mechanical, electrical, civil, structural materials science is a big factor as well these days, especially as they're trying to build turbines that are lighter weight. So materials are a factor. Even just basic physics, having a degree in physics.
Sure.
People have applied that towards the wind industry.
I fall down a lot. Is that part of physics? Would I qualify?
You're obeying the law of gravity there.
Oh, I'm not one to obey laws very well, so that's good for me.
That's yeah, really. That's a good demonstration. And also, I should say that there are synergies between wind energy and solar. In some fashions. Oh, and the whole power system side of things, like the power grid and that whole system, there's a lot of need for smart people to go into that space, because a lot of power systems engineers are reaching retirement age, and this has to do the whole utility system side of things. There's opportunities coming there because there's new technologies, a lot of need to kind of mix in all these different types of energy generation now with smart meters, and that's a fascinating area of big development, especially with this transition towards more electric vehicles. So you've got more electricity demand on the grid. That's going to continue, and need to build more transmission or rebuild the transmission that we have just because it's aging. So a lot of opportunities, really fun, interesting, challenging. Like if people think that, gosh, well, there's not really that much more to be invented and all that, I say, nope, there's so much need. Yeah, phooey to that. A lot of opportunities. It's a very, very exciting time from my perspective for the generation that's coming into the workforce now, or kind of new in their careers, or I don't know, people to meet the challenges that we have of today, climate change being one of the major ones. We just kind of need all hands on deck.
Sure.
No pun intended there.
Yeah. We'll have lots of resources because, Ruth, I know you've got lots of links and things that people can learn about a lot of things. You've got a movie to show us as well from YouTube. So check out our Facebook page and other resources that we have out there. We'll pass that stuff along to you as well. And if you want to learn more about wind and saving the world, that would be great. Ruth Heffernan-Marsh, thank you so much for joining us here in Occupations. A pioneer for sure, doing incredible things for the world and taking science by storm. And newly retired, congratulations again. And thank you so much for joining us today.
Well, thank you, Andy. It's been an absolute pleasure, and I really appreciate the opportunity to share. Thank you so much.
Thank you. And join us again for another episode of Occupations coming soon.
Occupations has been brought to you by lotsofmaps.com. Please follow Occupations the podcast on Facebook and Instagram to find information about our next episode or to see what past episodes are available.